All right, we're back. We're on page 8 of note 16 of Calc AB, and we're talking about definite integrals, fundamental theorem, and now we're going to talk about the candidates test. So why does the candidates test get involved again? It gets involved again because more often than not, you're given f prime. And so if you have f prime and you know how to do the fundamental theorem, you can find values of f. And so we can actually now use the candidates test in a lot more circumstances. So hopefully you recall, candidates test, if a function is continuous on a closed interval, it doesn't need to be differentiable, it just needs to be continuous. Continuous on a closed interval, absolute max, absolute min occur at an endpoint or a critical point. So it's kind of like a formula for, or at least like a plan for how you're gonna find the absolute max and min. So let's see if we can do this problem, which hopefully is related to that, but you really never know. F of x is a function passing through 2, 6, and whose derivative, f prime, is shown below. Use the information to answer the questions. All right, so find and classify the critical points of f of x on the open interval. It's almost always an open interval, so you don't have to like deal with like, what do I do at an endpoint? Critical points are where the derivative is 0 or undefined. So critical points of f of x are x equals -4, x equals 1, and x equals 5. All right, so we got the critical points. Now what we want to do is classify them. So I'm going to group them together. At -4, f prime changes negative to positive. At 5, f prime changes negative to positive. So at both of those, you have a relative minimum. So I'm going to say f of x has relative minimum at x equals -4 and x equals 5 because f prime of x changes negative to positive there. Okay, and then at x equals 1, f prime changes positive to negative, so that'll be a relative maximum. So let's write that. F of x has relative maximum at x equals 1 because f prime, so this should feel very familiar. Changes positive to negative there. You've been doing it for a long time at this point. Honestly, if you were in math analysis, you've been doing this since like late May of the year you took math analysis, so like last year probably. X coordinates of points of inflection. So points of inflection on the first derivative. So points of inflection of f of x on the first derivative are the relative extrema. So at x equals 0, there's a point of inflection on f of x. At x equals 2, there's a point of inflection. Now there's two places where f double prime doesn't exist. F double prime does not exist at -4 because f prime is not differentiable. This actually like breaks a little bit, right? Here you go over 4 and up 3, and here you go over 4 and up 2. So f double prime of -4 doesn't exist, but there's no sign change there for f double prime because f prime goes increasing to increasing, just increasing one way to increasing a different way. So not there. And then 5 is the same situation. F double prime of 5 doesn't exist, but there's no sign change in f double prime, so not a point of inflection. So I'm going to say the points of inflection on f of x are 0 and 2 because those are the relative extrema of f prime of x. So f of x has points of inflection at x equals 0 and x equals 2 because, so we're looking at the graph of f prime, so I believe my explanation should involve f prime because f prime of x has relative extrema at those values. So if you don't like that, you could say that f prime changes from increasing to decreasing or decreasing to increasing at those values, which is a more generally applicable justification. Like for example, if this line segment here was moved up 1 unit, then, or I don't know what the slope would be there. If it was here instead, then f prime still changes from increasing to decreasing. It just doesn't have a relative extrema there. So like it's a more generally applicable answer justification to say like changes increasing, decreasing, decreasing, increasing. But it's up to you. So I like to use relative extrema, so I'm going to, but you know, it's your call. Find the absolute max, absolute min on -8 to 7. Okay, so how do we start this out? We say f of x is continuous. Do we know that f of x is continuous? Like, we know it, but like, was it given or something? Okay, so why is f of x continuous? It's continuous because f prime exists for all x, so f of x is differentiable. So let's say, I'm gonna say f of x is differentiable, which implies continuous on -8 to 7. All right, so I always like to like explain why I'm allowed to do something. Therefore, by Candidates Test, absolute max, min, at endpoint or critical point. And now what we do is find the values, right? So we know that it goes through 2, 6, which is like a really annoying point to be given because it's not even one of the critical points. So great. But we can find all the values that we need. So we need to know, and where should I, so I'm gonna make a table. Where am I gonna make my table? I'm gonna move this stuff over. What am I doing? I wanna move everything to the side so I can like fit a table somewhere. Should have spaced this out better. Okay, my table is gonna be over here. It's gonna be x, f of x. And then for f of x, I'm always gonna be doing the value that I know, so 2, 6, right? So I'm gonna do 6 plus the integral from 2 to x of, let's say, f prime of t dt. So we have to use what's called a dummy variable, because if I just use x, then when x is 3, I'll make this 3, but then this would be a 3 also, and like it doesn't make sense. So use a dummy variable. We'll talk about that a lot more, but like just, you don't want it to be the same value variable. You want it to be something a little different. So I typically use t if it's available. All right, so we need to know -8, and then critical points were -4, 1, and 5. 4, 1, 5, and then we need to know 7. All right, so let's see if we can find those, because we don't actually know any of them. So I'm gonna find some areas here. This is 3 by, so 6, so -3, and then this is 2, 4, 8, so that. All right, so f of 5 is going to definitely be the 6 that we start with plus the integral from 2 to 5 of f prime of t dt. So that's going to be 6 plus -3, so it's 3. F of 7. So f of 7, what I can do is I can just go 3 plus the integral from 5 to 7 of f prime of t dt. So that's going to be 3 plus 4. So that's 7. So 3 and 7. I'm going to fill those in. This is 3. This is 7. And then, okay, so this is -1. So f of 1 is going to be, I'm going to say 6 minus the integral from 1 to 2. Right, because 6 plus the integral from 2 to 1, but you switch it and change the sign. So minus the integral from 1 to 2 of f prime of t dt. So that's 6 minus -1. So that's 7. And then what else do I need? -4. F of -4. So f of -4, I think I'm going to jump, I'm going to do 7 and then like go from there. So it's 7 minus the integral from -4 to 1 of f prime of t dt, right? Because 7 is the value at 1. So now the integral goes from like 1 to x, but I flip it and change the sign again. So I need to know that area. So what is this? This is 5 by 2 is 10, but it's a triangle. So half of that, so total is 5. So this will be 7 minus 5, which is 2. And then we need f of negative 8. So I'm going to say is 2 minus, because I'm going backwards, minus the integral from negative 8 to negative 4 of f prime of t dt. So if you're not sure about any of these, like write out the full fundamental theorem. So like f of negative 8 minus f, what am I doing? The integral from negative 8 to negative 4 is f of negative 4 minus f of negative 8. And then just fill in the blanks and solve. So this is 4 by 3 is 12, but half, so negative 6. So this is 2 minus negative 6, which is 8. All right, so what do we got? 8, 8, 2, 7, I think is the order in which I have to fill these in. Yeah, 8, 2, 7. So do these answers make sense? So I went 8, 2, 7, 3, 7. 8, 2, 7. It makes sense. This I said was a minimum. So it's 8, 2, 7, 3. What? 8, 2, 7, 3. So, okay, yeah. 8, 2, 7. This was a minimum. Good. And then it's 8, 2, 7, 3. 7, that was a maximum. This is a minimum. Yeah, I mean, they follow sort of generally what I said. So I think it's okay. All right, so therefore, absolute maximum is actually 8. And the absolute minimum is actually 2. So, all right, therefore, absolute maximum is 8 at x equals negative 8. And absolute minimum is 2 at x equals negative 4, which was also a relative minimum. Does that make sense? Endpoints, nothing you can do. They're not critical points, so like you never tested them. Anything could happen there. So in this case, we had a maximum at an endpoint, a minimum at a critical point. Awesome. Hopefully it's right. All right, find any value c such that the instantaneous rate of change at x equals c equals the average rate of change of f of x on negative 8 to 7. If such a value exists, was it guaranteed? Why or why not? How? Okay. So first, let's find the average rate of change. Algebra 1 slope. This question feels like a mean value theorem question, but it's kind of not. It's like the setup of the mean value theorem, but like not. Like you're not required to use it. So 7 minus 8 over 15. So negative 1/15. Okay, so this should be equal to f prime of c. Yeah, all right. So negative 1, there's like 3 of them. How do I know that? So I think there are 3 because negative 1/15 is kind of like through here. So I need to find this, this, and this. Oh, that's so much math. All right. Okay. So let's do the math. And I'm gonna write the equation, I guess, of this and then intersect it. So what's the slope here? 4, 3. So it's like y minus 0 equals 3/4. 3/4 x plus 4. And then I'm gonna have to set that equal to negative 1/15. So the work is gonna be all over the place here. 3/4 x plus 4, negative 1/15. So what should I do? Distribute, I guess, 3/4 x plus 1. So let's make it minus 16/15. Multiply by 4, divide by 3. Negative 64 over 45. Does that make sense? That's like, that's totally wrong. Is that totally wrong? Yeah, I mean, that can't be right. It should be like negative 4 point something, and I got nothing even remotely like that. 3/4 x plus 1. Negative that. Negative 64 over 45. It's like you always, what am I doing wrong? Hold on, let me just, what am I doing wrong? I'm solving this on the calculator just to, like, you know, not waste everyone's time. So annoyed. Solve it for x. -1. Why? Why? 3. It's not 1. All right. Hold up. Hold up. My problem is here. I'm subtracting 3, 45, so 46. And then 46 times 4, 160, 184. I'm pretty sure the calculator said, yeah, 184. That makes more sense. 184. Okay. -184 over 45. Okay, so let's see. Therefore, C equals -184 over 45. Let's find the others. Let's try to get them right. So this is y equals 2 minus 2x. So 2 minus 2x equals -1/15. Subtract 2 gives me -31 over 15 is -2x. So x is 31 over 30, which makes sense. It's like very close, I think, to, it's very close to 1. So 31 over 30. This, you end up doing a lot of like Algebra 1. 31 over 30. Oh, that should be C equals. Or C equals. One more. All right, what are you? You are y equals up to over 3, 2/3 x minus 5. So 2/3 x minus 5 equals -1/15. This is not my best work. Sorry. I'm going to multiply by 3, divide by 2. X minus 5 equals multiply by 3, divide by 2, -1/10. And then if I add 50 tenths, I get 49 tenths, which is 4.9. It definitely looks like it could be that. So 49 tenths. And then let's decide if these values were guaranteed. So f of x is differentiable and therefore continuous, and therefore the mean value theorem applies. So these were guaranteed. It was guaranteed, at least one was guaranteed. So at least one value was guaranteed by the mean value theorem, because f of x is differentiable and therefore continuous on -8 to 7. Whew, okay. That right there, that could be a free response question in May when you take the AP exam. Like every part of that could definitely be a free response. It's actually a really common type of free response question. I call them like given the first derivative, interpreting the first derivative. So good problem. I'll be back in the next video, do some more. It'll be the last page of the notes. Maybe we'll get it done. Who knows? I will see you there.